Hello my friends, and welcome back to Sky Creative Channel. I'm your host, and today we're taking an incredible journey through 7 of the world's most fascinating production facilities. Let's dive into the mesmerizing world of modern manufacturing. Our first stop takes us inside Paper One's state-of-the-art facility, where ancient paper making meets 21st century innovation. What you're seeing here isn't just paper production, it's industrial poetry in motion. NTHE Journey begins with their massive headbox system. This engineering marvel spans the entire width of the production line, distributing fiber suspension with mathematical precision. Notice how the dilution water system creates that perfectly uniform sheet formation. The headbox operates at pressures exceeding 40 psi, ensuring consistent basis weight across every inch of paper. Now watch this impressive forming section. Those aren't just conveyor belts, they're precision-engineered forming fabrics made from polyester monofilaments. The paper sheet is actually born here, as millions of cellulose fibers interlock under carefully controlled suction pressures. The dewatering process removes 80% of the water content in just seconds through a series of vacuum boxes operating at different intensities. Here's where it gets really fascinating: the press section. These massive steel rollers, each weighing several tons, apply up to 1,000 pounds per linear inch of pressure. But it's not just brute force. The nip pressure profile is precisely engineered to gradually increase water removal while maintaining sheet integrity. The heated press rolls operate at temperatures around 200 degrees Fahrenheit, beginning the drying process. NTHE crown jewel of this operation is their multi-cylinder drying section. 48 steam-heated cylinders, each maintaining exact temperatures between 300 to 400 degrees Fahrenheit, complete the moisture removal process. The paper travels through this section at speeds reaching 6,000 feet per minute. That's over 68 miles per hour. Advanced moisture profiling systems continuously monitor and adjust steam pressure to ensure uniform drying across the sheet width. Finally, witness their super calendaring process. Multiple steel and composite rolls apply tremendous pressure to create that smooth, professional finish. The calendaring stack operates at pressures exceeding 2,000 pounds per linear inch, transforming raw paper into the premium product we know and trust. Step into the world of artisanal excellence with Sally Tescaredzic's award-winning lattice chair, brought to life by Artisan Solid Wood Furniture. This isn't mass production. This is furniture sculpture. And watch as master craftsmen begin with premium solid wood selections, using moisture meters to ensure each piece maintains the perfect 8 to 12% moisture content. The precision here is remarkable. Every measurement matters when you're creating furniture that will last generations. NTHE magic starts with their CNC routing system, a computer-controlled marvel that translates Tescaredzic's S-exact design specifications into precise cuts. This 5-axis CNC machine moves with incredible accuracy, creating those signature curved elements that make the latest chair so visually striking. The spindle rotates at 18,000 RPM, while carbide cutting tools remove material with tolerances measured in thousandths of an inch. Notice the steam bending process. This centuries-old technique meets modern precision. Selected wood pieces are subjected to steam at 212 degrees Fahrenheit for carefully calculated time periods based on thickness, then slowly curved using custom-made forms. The wood's lignin temporarily softens, allowing for those elegant curves without compromising structural integrity. NTHE hand sanding process is where true artistry emerges. Starting with 80 grit sandpaper and progressing through 120, 180, and finally 220 grit, each surface is meticulously prepared. You can see how the craftsman's experienced hands detect even the slightest imperfections, ensuring every surface meets artisans' exacting standards. Welcome to Tech's workshop in Italy, where traditional craftsmanship creates beautiful wooden accessories using methods passed down through generations. This is manufacturing as art form. NTHE process begins with their wood selection. Carefully chosen pieces of olive, beech, and other premium woods are stored in climate-controlled conditions. Notice how the craftsman examines each piece, reading the grain like a book to determine the best cutting pattern. This isn't just about efficiency, it's about honoring the natural beauty of the wood. Watch this fascinating turning process on their traditional lathes. The woodworker's hands guide the cutting tools with practiced precision, creating perfectly rounded brush handles and comb bodies. The lathe rotates at carefully controlled speeds. Too fast and you risk tear out. Too slow and you get burn marks. It's all about finding that perfect balance. NTHE drilling operation for brush holes is equally precise. Using specialized drill bits, each hole is created at exact depths and angles to ensure the bristles will sit perfectly. The drill press operates at specific speeds for different wood types. Harder woods like olive require slower speeds and sharper bits. Here's something special: their hand finishing process. Each piece receives individual attention, with craftsmen using traditional hand planes and scrapers to achieve that silky smooth finish. You can see how the wood shavings curl perfectly, a sign of properly sharpened tools and skilled hands. NTHE final assembly is pure craftsmanship. Natural bristles are carefully sorted by hand, then inserted and secured using time-tested techniques. Each brush is tested for balance and feel before receiving the tech stamp of approval. This is why their products last for decades. It's not just manufacturing, it's a commitment to excellence. Now let's explore the fascinating world of synthetic fiber production at Sky Cotex India Private Limited, where cutting-edge polymer science meets precision engineering. NTHE process begins in their polymer preparation area, where polyester chips are heated to precisely 285 degrees Celsius in their massive extruders. These aren't ordinary heating systems. They're sophisticated polymer processing machines that maintain temperature uniformity within plus or minus 2 degrees Celsius across the entire heating zone. The molten polymer reaches a honey-like consistency, ready for the transformation ahead. And watch this incredible spinning process. The molten polymer is forced through spinnerets, precision-engineered plates containing thousands of microscopic holes, each just 0.3 millimeters in diameter. These spinnerets are manufactured to tolerances measured in microns, because even tiny variations would affect fiber quality. As the polymer streams emerge, they're immediately cooled by precisely controlled air currents. Here's where the magic really happens: the drawing process. These fibers are stretched at ratios up to 4:1 while being heated to specific temperatures. The drawing frames operate with incredible precision. We're talking about controlling fiber tension to within 0.1 gram force while maintaining speeds of 3,000 meters per minute. This process aligns the polymer chains, giving the fibers their strength and desired properties. Notice their texturizing equipment. This is where smooth filaments get their distinctive crimp and bulk. The yarn passes over heated surfaces at temperatures around 200 degrees Celsius while being mechanically deformed. The false twist spindles rotate at up to 2 million RPM. That's faster than a Formula One engine. This creates the texture that gives the final fabric its handle and appearance. NTHE quality control here is remarkable. Continuous monitoring systems check fiber diameter, tensile strength, and elongation properties. Any deviation from specifications triggers immediate adjustments to the process parameters. Their electronic yarn clearers can detect and remove defects as small as 30% diameter variation while running at full production speed. And finally, the winding process, where precision wound packages are created using programmable winding patterns. These patterns ensure even distribution of yarn layers, preventing soft spots that could cause problems during downstream processing. Journey with us to Syria's ancient city of Aleppo, where soap-making traditions dating back over 2,000 years continue today. This isn't just soap production, it's cultural heritage in action. NTHE's story begins with the olive oil, the foundation of authentic Aleppo soap. Master soap makers select only the finest second-pressing olive oil, which contains the perfect balance of oleic acid and natural moisturizing compounds. The oil arrives in massive containers, each batch tested for purity and acid content. Traditional Aleppo soap requires oil with specific characteristics. Too much acid and the saponification process won't work properly. Watch this fascinating preparation phase. In enormous copper cauldrons that have served families for generations, the olive oil is heated to precisely 80 degrees Celsius. These aren't modern heating systems. They're wood-fired cauldrons where temperature control requires years of experience to master. The soap maker constantly stirs with traditional wooden paddles, reading the oil's behavior like a master chef. Now comes the critical moment, adding the bay oil. This isn't just any bay oil, but oil extracted from Laurus nobilis berries grown in Syria's coastal mountains. The percentage of bay oil determines the soap's grade and price. Premium soaps contain up to 40% bay oil, giving them distinctive green color and therapeutic properties. Watch how the master soap maker adds the bay oil in precise measurements, stirring constantly to ensure even distribution. NTHE's saponification process is pure chemistry in action. Sodium hydroxide, lye, is slowly added to the heated oil mixture. This isn't store-bought lye. It's traditionally made from barilla plant ashes, though modern producers may use commercial-grade sodium hydroxide for consistency. The chemical reaction transforms oils into soap through a process called saponification. The sodium ions bond with fatty acid chains to create soap molecules. Notice how the mixture changes color and consistency. The master soap maker judges the process not by thermometers or timers, but by sight, smell, and feel. The mixture must reach exactly the right consistency. Too thin, and it won't set properly. Too thick, and it becomes difficult to pour. This requires intuition developed over decades of practice. Here's something remarkable: the pouring process. The hot soap mixture is poured onto large, flat surfaces covered with wax paper. These surfaces must be perfectly level, and the soap must be poured quickly before it begins to set. Workers spread the mixture with large wooden smoothers, creating an even thickness across the entire surface. The soap is typically 3 to 4 centimeters thick when set. NTHE cutting process is an art form itself. Using traditional cutting tools, workers create perfectly uniform bars. The cuts must be made at exactly the right time. Too early and the soap won't hold its shape. Too late and clean cuts become impossible. Each bar is hand-cut to traditional dimensions that have remained unchanged for centuries. Now begins the most critical phase, the curing process. The soap bars are carefully stacked in tall towers, allowing air to circulate freely around each bar. This isn't just drying. It's a complex chemical process where residual moisture evaporates while the soap continues to mild and develop its characteristic properties. The curing rooms are carefully climate-controlled, maintaining specific temperature and humidity levels. NTHE aging process takes minimum 6 months, but premium soaps may age for over 2 years. During this time, the soap gradually hardens, the excess alkali neutralizes, and the color develops from green to the characteristic pale gold. Master soap makers regularly inspect the aging soap, turning bars periodically to ensure even curing, and quality control in Aleppo soap making is entirely traditional. Experienced soap makers test each batch by feel, smell, and appearance. The finished soap should be hard but not brittle, with a smooth surface free from cracks or white spots that indicate poor saponification or curing. Step into England Furniture's facility, where traditional furniture making meets modern precision. This Tennessee-based company has perfected the art of creating comfort that lasts. NTHE process begins with their frame construction. Watch as skilled craftsmen assemble solid hardwood frames using time-tested joinery techniques. These aren't particle board frames. We're looking at genuine hardwood construction with mortise and tendon joints, doweled connections, and corner blocks for maximum strength. Each joint is glued with industrial-strength adhesives and clamped under precise pressure to ensure permanent bonds. Notice their spring system installation. This is where comfort truly begins. 8-way hand-tied springs are individually positioned and secured to the frame using specialized spring clips. Each spring is then hand-tied to its neighbors using strong twine in a pattern that distributes weight evenly while providing responsive support. This process requires significant skill. The tension must be perfect to prevent sagging while maintaining comfort. And watch this impressive fabric cutting operation. Using computer-controlled cutting tables, patterns are precisely cut from upholstery-grade fabrics. The cutting heads use reciprocating knives that can handle multiple fabric layers while maintaining clean, accurate cuts. Pattern matching is critical. Stripes and patterns must align perfectly when assembled. NTHE final upholstery process showcases true craftsmanship. Skilled upholsterers stretch and secure fabric using pneumatic staplers, ensuring proper tension and smooth appearance. Our final stop takes us to Arend's Dutch facility, where office seating becomes a science of comfort and durability. NTHE journey begins with their advanced injection molding operations. Arend's molding machines are massive, some capable of 1,000-ton clamping force. Watch as thermoplastic pellets are heated to precisely 280 degrees Celsius and injected into steel molds under tremendous pressure. These molds are precision-engineered works of art, manufactured to tolerances of plus or minus 0.05 millimeters. The cooling process is equally controlled, with temperature-controlled cooling channels ensuring uniform part shrinkage and dimensional accuracy. Notice their sophisticated testing equipment. Each chair component undergoes rigorous testing before assembly. Seat mechanisms are cycled through 200,000 operations to simulate years of use. Back supports are subjected to precise loading tests, ensuring they'll provide consistent support throughout their service life. This isn't just quality control, it's engineering validation of every design decision. NTHE assembly process combines automation with skilled craftsmanship. Robotic systems precisely position components, while human technicians perform final adjustments and quality checks. Watch how the gas cylinder is carefully installed and tested. Each cylinder must meet exact pressure specifications to provide smooth height adjustment throughout the chair's life. Here's something impressive: their fabric cutting and sewing operations. Computer-controlled cutting systems create perfectly precise fabric pieces, while specialized sewing machines designed specifically for upholstery work create strong, consistent seams. The sewing machines operate at up to 5,000 stitches per minute, while maintaining perfect tension control. NTHE final assembly showcases Arend's attention to detail. Each chair receives individual adjustment and testing. Ergonomic settings are verified, mechanisms are tested for smooth operation, and every surface is inspected for quality. The finished chairs undergo final testing, where they're subjected to standardized loading conditions to verify they meet international safety standards. Quality assurance here goes beyond visual inspection. Random samples undergo destructive testing, durability testing, and even comfort evaluation by trained assessors. This comprehensive approach ensures every Arend chair meets their exacting standards for comfort, durability, and safety.